Okay, now let's have a little more fun here. Let's combine functions that aren't inverses of each other. For example, sine of cosine inverse of negative root 3 over 2. Okay, so for each of these parts, I'm going to go off to the side and deal with working my way inside out. So I'm going to leave a space here, okay, for sine of some angle. And I'm going to note for part A that cosine inverse of negative root 3 over 2 is an angle, let's call it y, where cosine of y is negative root 3 over 2, and I can only pick y to be in the first or the second quadrant. We know the reference angle is pi over 6 radians from our triangles. You have to constantly review those triangles. We know that we can pick between quadrant 1 or quadrant 2 for cosine inverse. We know that of these two, cosine is negative in quadrant 2. So that's how I'm making my reasoning. Okay, so back to our reasoning here. So we're choosing the pi over 6 angle that is in quadrant 2. So that's pi minus pi over 6, otherwise known as 5 pi over 6. Okay, that's stage 1. All right, now we know that the sine of 5 pi over 6 is related to knowing the sine of pi over 6. We know that the sine of pi over 6 is 1/2. We know that in quadrant 2, sine should be positive. So sine of 5 pi over 6 will be positive 1/2. Some of you may have taken the time to certainly memorize a unit circle. That may speed things up for you, but I'm going to do this the derivation manner. Okay, since I've emphasized the triangles, which the triangles are what you use to produce a unit circle in the first place. Okay, second question. Cosine of tan inverse of 1 is going to be cosine of something. Okay, so that requires that we understand what we mean by tan inverse of 1. Well, tan inverse of 1 means that tangent of some angle is the value 1, and that you can only look in quadrant 1 measured positively and quadrant 4 measured negatively. So one going this way and one going this way. Okay, well, if tangent is positive 1, then out of the quadrant 1, quadrant 4 choices for inverse tan, then we've got to choose the quadrant 1 version, and the reference angle is 45 degrees, or pi over 4, for tangent to have a value of 1. So we're looking for the value of cosine of pi over 4. Now we know that same reference angle, same triangle. We know that the cosine of pi over 4 is 1 over root 2, and some of you prefer to write root 2 over 2. Okay, and then lastly down here, tan of sine inverse of 1 means we're doing tan of something. Sine inverse of a number is an angle, so that sine of the angle is the number. So in this case, we're looking for an angle between negative pi halves and pi halves whose sine value is 1. Now in this case, the endpoints are included because sine does not have any asymptotes. We know that sine having a value of 1 or 0 or negative 1, that's a quadrantal angle. And we know that for sine to be 1 in this window, the angle would have to be pi over 2. Now, here's where it gets interesting. We know that tangent of pi over 2 does not exist because pi over 2 is a position where tangent has an asymptote. So the answer here would be undefined. And yes, to save trouble, put it in just like they have it, all caps, etc.